what is the vector in FSC, or conventionally we say that in metric and FSC we say that the quantity which require magnitude, unit, and third direction. Okay, these are these quantity which have magnitude, unit, and direction are defined as a vector in FSC. Okay, in a metric, or a conventional definition was that. But we know there are some many quantities like for example, but not true. Not complete, okay, are true. Why? Because there are many quantity which have magnitude, unit, and direction, but they are not vector quantity. Like current, rotation. I have already explained why they are not vectors. I have already explained that the current because it don't obey the law of vector addition. Current has a magnitude because the direction of the current has a magnitude. The number of charge per unit time passing through any specific area is defined as a current. It has a magnitude, it has a unit ampere, it has a direction of the flow of the charge will be, but it is not a vector. Similarly, rotation, because they don't obey the law of vector addition. Similarly, rotation has a magnitude, angular displacement. Okay, rotation has an angular displacement, and you may measure, and it has a unit. You know that may be a radian and degree. Okay, you may choose the most favorite unit is the radian, but you may choose the degree or a radian. Okay, and similarly, it has a direction. The direction of rotation, you know that the rotation has a direction, but these don't. Why they don't obey the? I have experimentally performed that rotation don't obey the law of vector addition. So all these, because like are not vector, are not vector. Even then they have magnitude and unit and direction. But what are the vectors? Vectors are the quantity which obey the 9 properties of the vector space. Okay, they must make a billion group under addition and etc. Okay, so but in the sense of rotation or transformation, what is the vector? We have discussed in the previous lectures what is the vector in the form of the transformation. So we know that under transformation there are two types of transformation. When we perform a transformation, if we throw it toward anything, there will be two types. One, number one, it will be change its position. For instance, it is here, and at other instant, if I throw it, will be after passes some time, they will be at other place. Okay. So one transformation is that it will move from one place to other place. This is one type of transformation. Okay. The other type of transformation, what will be the other type of transformation? Yes. क्या हो सकती है? एक तो ये होगी, दूसरी क्या होगी? One type of transformation, change of the position, change of the origin. ठीक है? And the other transformation, yes. नहीं, this is if you move from one point to other point, that is defined as a change of origin. That is defined as a translational transformation. This will be defined as a translational transformation. The other changes I have already explained. No. चेंज क्या आएगी? जब भी कोई चीज मूव करती है, दो तरह की ट्रांसफॉर्मेशन होती है. क्यों? कौन? Yes. The other change is the direction change means the rotation about their own axis. That is defined as a spin. Okay, and in physics sense, that is defined as a rotation. If you move, if I throw this one this is moving and it may be a spin around their own axis. So there will be a two type of the transformation always occur. Number one, the change of the origin, that will be defined as a translational transformation. The other is the rotation about their own axis, that will be defined as a spin, okay, or they define as a rotation, okay. In physics sense, we usually define as a rotation, okay. So if you have two axes, okay, if we suppose that this is vector A, okay, this is X, this is Y, this is Z, motion from here to here, the one point to other point, okay, that will be defined as a translational transformation, okay, from O to O prime, this transformation O prime, okay, this is X, Y, Z axis, okay, the black will be, so this axis will be, let's suppose this X, Y and Z axis, okay, it is also rotate about their own axis. This was making angle theta, this was making angle theta with y-axis. So here, because I am rotating the frame itself, so that's why this A vector. Now, but this is not A. Now, because it has changed the rotation, so that will become A dash, A prime. Okay. A prime. Okay, and this is also making angle, the same angle with y-axis theta. Okay, and I should define that is x, y, because this is a different. Okay. Okay. So there are two type of transformation occur. Okay. Number one, the distance between O and O prime. Okay. This transformation is, I say that there are two type of transformation. One is, this is, okay, I must not write in the form of tensor because you are in undergraduate level, so I will write in the form of rotation. And there, actually this axis is rotated. If this axis is rotating along this theta is fixed, but this axis is rotating along the phi angle, okay. So this one transformation is rotation, okay. One transformation is rotation, that is changing with respect to angle phi, okay, because theta is fixed, okay, the phi is, okay. And the other change is distance A. This is A distance. If you ask what is the A is this distance, the distance between two origins. Okay. So there are two type of transformation. One is the rotation, one is the translation. So these are the transformation of vector. So vector will be transformed in a two way. Okay, there are two type of transformation. Number one, translational transformation. That will be representing by A. Okay, I have represented by A. Okay. I may say that the transformation of origin. Okay. So these type of transformation is defined as a translational transformation. Have you got it? What is the translational transformation? The transformation of the origin is defined as a translational transformation. Okay, the second transformation is about the rotation. Okay, rotation it doesn't mean rotate. The rotation जो आपको जानते हो जिस rotation को that will be defined as a translational transformation क्योंकि वो origin change हो रहा है. Rotation means जिसकी direction change हो. ठीक है? The rotation means the rotation about their own axis like a spin. That is a spin. Okay. So rotation. Okay. The other is the rotation, and that is अच्छा इसको बाद में लिख लेते हैं पहले इसको बताओ. Under the translation transformation vector A will remain always the A. There will be no change. आप A vector को अगर उसकी direction change नहीं हो रही, if the magnitude and direction is the same, if A vector is placed here, they will always remain the A. There will be no change in a vector. Got it? Under translation transformation, there will be no change in a vector. Under translational transformation only, there will be no change in vector. Mean A vector will remain if this is A vector. If I perform only the translation, if there is a no translational transformation, only means there is a no rotation or there is no change in a direction, that will be remain the vector A. Okay. So mean if this vector A is placed here, okay, if it is at origin O, if I take it and put it here, then and if if there is no change in a direction, okay, then this way, if for example if this position is O, if this position is O1, okay, or O prime, okay, then this vector will remain the, there will be no change. If I put it here, this will be remain the A vector, even if I am changing the places. So if something is moving from here to here, A vector remain the A. There will be no. In that case, A dash mean if I say that A dash is the new vector, A dash will be remain the A. In that case, under the translational transformation. Under translational transformation, vector A will remain always the A. There will be no change in a vector. Okay. Okay. What about the second transformation? Yes. May I erase it? Okay. So in the case of under the translational transformation, A dash is remaining the A dash will remain the A. Okay. But the condition is only if there is only transformation. If there is no rotation. Okay. Got it? The other type of transformation is rotation, and it will be it is representing here by I am representing it R phi. What is the phi? Phi is the angle of rotation. Okay, where phi is angle of rotation. What is that? That is transformation about on axis. It's on axis. अपने ही axis के गिर्द की rotation को क्या कहते हैं? That is in the common sense we say that is the spin. Okay. So in that case, that transformation, in that case vector will be changed. In this case, A will not remain, because if there is a translational transformation, A will not remain the A. That will become a A prime. Okay. In that case, under such transformation vector will be changed. Okay, how it will be changed? It will be changed means A prime will be, if in this case A prime will be not equal to A. Okay, in this case A will not equal to A, but there is some condition. What is that condition? But magnitude of A will remain the same because components of vector will be transformed. The component of vector will be transformed in such a way that magnitude of vector will remain the same. Okay, magnitude ax prime will not equal to ax, ay prime will not equal to ay, az prime will be not equal to az, in such a way that a square will be equal to, that is a dot a. We may find only the magnitude by taking the dot product with itself. Okay, so that will be the magnitude, that will be remain the a square will be equal to a prime square. Okay, the magnitude will remain the same. Okay, axis will be not equal to ax. Component, all components will be transformed because component will be not same. Component है ना, ax prime will be not equal to ax, ay prime will be not equal to ay. आप कुछ पूछना चाह रही हो, क्या कहना है? कंपोनेंट विल नॉट ट्रांसफॉर्म, बट ये मैग्नीट्यूड हमेशा डॉट प्रोडक्ट से आता है, यानी ए स्क्वायर मीन इसकी मैग्नीट्यूड. ठीक है, ये ए से ए डॉट प्रोडक्ट लेंगे या ए प्राइम की डॉट प्रोडक्ट लेंगे, दैट विल बी रिमेन द सेम. ठीक है, इन अदर सेंस अगर मैं इसे लिखना चाहूँ, इसको इस तरीके से भी लिखता हूँ जो पिछली दफा कहा था, वो इस तरीके से भी लिख सकता हूँ. ए एक्स स्क्वायर प्लस ए वाई स्क्वायर प्लस ए जेड स्क्वायर, दैट विल बी इक्वल टू ए एक्स इंडिपेंडेंटली एक जैसे नहीं है. जब भी डॉट प्रोडक्ट लेते हैं तो एक्स एक्स के साथ मल्टीप्लाई होता है, वाई वाई के साथ मल्टीप्लाई होता है, जेड जेड के साथ मल्टीप्लाई. बट इसके कंपोनेंट जो हैं ये क्या रहेगा, सेम रहेगा. समझ आ गई? ये डॉट प्रोडक्ट पढ़ा हुआ है ना आपने? ठीक है, समझ आ गई? हाँ, वो ही रिपीट करवाया. ठीक है, ये क्लियर हो गया? ठीक हो गया? ओके. चल ठीक है, रिपीट ही है. ठीक है, ओके. हाँ ठीक है, लेकिन इसमें ठीक है, समझ आ गई? उसी तरीके से ही है, हम कर भी वही रहे. ठीक है, और आपके पास क्या आ जाएगा, डॉट प्रोडक्ट क्या होता है? एज आई हैव ऑलरेडी एक्सप्लेन, ए स्क्वायर विल बी ऑलवेज इक्वल टू ax, ay, az. मैंने क्या कहा है, a dot a, and this will be equal to ax, ay, az. I may write it in the form of the column, okay, and this will be dot ax, ay, az. Okay, when we take the dot, the first side will be as a we have to take the transpose, that will be equal to a, so that if I take the transpose of this, that will be a ax, ay, az transpose ax, ay, az. This will be equal to this. Okay, when we write in the form of ax, ay, az, ax, ay, az. So this will be ax square plus ay square plus az square. This will be equal to this. Okay, and this way must be remain same. That will be equal to this is our constant invariant. Why invariant? Because a dash square will be ax square, ay square, a dash square, az dash square, and this will be equal to a square, that is equal to ax square plus ay square plus az square. Okay, so if I combine 1 and 2, so the same thing will be true. The same thing will be true for both type of transformation, because इसमें आपकी मैग्नीट्यूड मतलब अंडर रोटेशन एंड अंडर, देखो मैग्नीट्यूड तो अगर वेक्टर सेम रहता है तो मैग्नीट्यूड सेम रहती है, तो अंडर बोथ ट्रांसफॉर्मेशन इफ आई कंबाइन 1 and 2, ओके, combining 1 and 2 under rotation as well as translational transformation in both transformation the same thing will be true, this and this, or this will be true, okay, and because in rotation the component is also a constant, under rotation vector is remain the same, under translational vector remain the same, so magnitude remain the constant, okay, invariant. Under rotation the magnitude constant. So if I combine 1 and 2, the under rotation and translation transformation both will be remain the same. Okay, got it. Okay, so यहाँ तक तो ये बात ठीक हो गई, but what about the Lorentz transformation? May I erase it? Under Lorentz transformation, under Lorentz transformation, yes. Under Lorentz transformation, what have we proved? No, that is also included in. That was a RA. Sorry. RA square equal to, okay, equal to CA is a T A square, and R B square equal to C square T B square. That was we have already proved. Okay, and under so we may say that R A square minus C square T A square equal to R B square minus, because both are equal to 0, and in actually in starting at this will be a 0. Okay, both are equal to 0, or B square minus C square T B square, both are equal to 0. But in more general form, उसमें हमने particular case लिया था, but in more general form, in more general form, I may say that R A square minus C square T A square is equal to R B square minus C square T B square. Okay, so this is the general form of the Laurent's transformation. Okay, both are a constant. Okay, this is the general form of the Laurent's transformation. Okay. Acha, why I have not erased it? Because you may say that this is a A frame, this is a OB frame. If I change it by the Umar, please. This is OA frame, okay. We have already, yes, ये अगर राइट पे जाएगा तो this will be equal to, ये इधर चला जाएगा राइट पे जाएगा, ठीक है, 0. Okay. If I say that this is A frame, this is a B frame, this is a A frame, this is a B frame, okay, this is a A frame, this is a B, so I must write this XA, YA, ZA, this is XB, YB, yes, or ZB, okay. So this this type of, if I say that this is, अभी मैं सिर्फ वो इंट्रोडक्शन मतलब आपको बताने की कि ये वेक्टर जो है यहाँ से जैसे ये ट्रांसफॉर्मेशन हो रही है, इसको हम अगर A एंड A प्राइम भी कह सकते हैं और A एंड B प्राइम भी कह सकते हैं, ठीक है, समझ आ गई. A एंड A प्राइम भी कह सकते हैं या A फ्रेम और B फ्रेम, मीन दे आर टू डिफरेंट फ्रेम. ओके, यस, हाँ जी, प्राइम भी. So, how we will explain it? What is this? This RA square is, I have already explained. What is the RA? RA square is x square plus y square plus, XA square plus YA square plus ZA square. Okay. Okay. So, and RB square is XB square plus YB square plus ZB square. Okay. So, if I put it in this, then that will become XA square plus YA square plus ZA square minus C square TA square. This is XB square plus YB square plus ZB square minus C square TB square. Now this is a form. Okay, and these are under transformation. These are a constant. So this will be a vector. In the old Galilean transformation, the vector has a 3 component, x, y, z. In Because now this is a conserved, because this is not changing after transformation. So it means these are the conserved, these are the length. Now the vector has not only 3 dimension, now vector is a 4 dimension. 1, 2, 3 and the 4. Okay? 1, 2, 3 and 4. Okay? So in that case, this is constant. Since left hand side and right hand side are equal, so it means it is invariant. And what is the meaning of this? If the thing is the invariant, then it is the length of the vector. So it means this implies that left hand side and right hand side are the length of vector in relative, in Lorentz transformation of relativity. Special theory of relativity में ये क्या है? This is not defined as a relativity. Actually, this is defined as a special theory of relativity. General theory of relativity is different. Special theory of relativity. This is defined as special theory of relativity. ठीक है? Okay. So it means the vector, A sign means the frame of reference. A means a different frame, B means different frame. So the length is preserved. If that is A, B, C, D, E, X, Y, Z, in any other frame, this length, this quantity will remain the conserved. So this will be defined as the length of the. So what is the length of vector? So length. So it means the length of vector is L square. If A square is a vector, then that will be a X square plus Y square. If I say that is capital X, okay, वैसे ही ठीक है. So generally मैं वेक्टर को X से represent करता हूँ. समझ आ जाएगी? या L लिखूँ? चलो L लिख लो भाई. आप disturb ना हो. minus T square. This is a conserved. Okay, this is the invariant. Okay, got it? And if I say this is the first component, this is second component, this third component, और दिस इज अ फोर्थ कंपोनेंट. अमूमन टाइम के कंपोनेंट को हम जीरो कंपोनेंट से कहते हैं. मैंने कंपोनेंट की फॉर्म में बताया था आपको. इफ आई से दैट दिस इज x1 स्क्वायर, दिस इज x2 स्क्वायर प्लस x3 स्क्वायर, दिस इज x0 स्क्वायर. ठीक है, दैट इज अ फोर कंपोनेंट. दिस इज L स्क्वायर. L स्क्वायर हैज अ फोर कंपोनेंट. x1, x2, x3. Time component is defined as a naught scale. Okay, ठीक है. So L square is actually L vector. This is okay, this will be equal to this. Okay. If I say this is a 1, this is a 2, if I compare the 1 and 2, okay. Comparing the 1 and 2, okay. The both are the same length. Okay, that will be the comparing 1 and 2. Okay, that's 1 and 2. Okay. X1 will be x1 square equal to x square. That implies that x1 will be x. Okay. X2 square y square will implies that x2 is y. X3 square to z square implies that x3 is equal to z. Okay. Yes. But x naught will be equal to x naught is equal to square equal to minus c square t square. This implies that x naught is equal to, when we take a square root, that will be iota ct. So fourth component will be the naught component will be iota ct. Okay. Okay, got it. So this is a four. It means under Lorentz transformation, vector has a 4 dimension, and time is not a constant, but it will be also transformed as a dimension. Okay. Got it? Okay. So this is the result, and I in the combined form. In the combined form, may I write it L square is equal to x naught x, sorry, if I change the position x1 x2, I may change the order. I may write the last thing at the first. I may write in this way the transpose. Okay. That will be x naught square plus x1 square plus x2 square plus x3 square, that is equal to minus c square t square plus y square plus z square, x square plus y square plus z square. And this is defined as signature minus plus plus plus. This is defined as the signature, because the first is minus 1. If I am saying that minus c square t square plus x square plus y square is constant, the constant can, if I multiply it with the minus 1, okay, if I multiply it and I multiply it with minus 1, then this will become a ct square minus x square minus y square minus z square. This will be minus constant. Minus constant will be a new constant. So I may say that this is also constant. Okay. So L square. So it is also a prism. This is a constant. Negative number is also a constant. Okay. So this is a constant. So this will be a constant. So we may also define L square as a c square t square minus x square minus y square minus z square as length in Lorentz transformation विथ सिग्नेचर क्या है, प्लस माइनस माइनस with minus, okay, plus minus minus minus, okay. In that case, what will be the vector L? That case L will be equal to, okay, and this will be equal to this, okay. But we will use this signature, okay. हम जो है अपने इसमें उमर, please be serious. So this will be the first component of CT, and the other component iota x, iota y, iota z. So actually this also this use in this signature used in a tensor, but we are not studying the tensor. That's why we will not use this representation, but we will use this signature. Okay. Okay. आगे से तो हमारा जो कंसंट्रेशन है वो इन सिग्नेचर, इस सिग्नेचर से करेंगे, ठीक है. और इस सिग्नेचर में हमारे पास L क्या है, अकॉर्डिंग टू दिस सिग्नेचर. What is L? According to this, L is iota CT x y z. This was a L. Okay, but we will use this signature. Okay, this is L. Okay. Okay. So 4 vector is according to 4 vector. लिखना है सब कुछ. So 4 vector, अब नया टॉपिक है, ठीक है. Lecture is about the 4 vector, okay, not about the 4 vector. So every vector, if I say that R is a vector, okay, in a 4 dimension, R is, असल में हम इसे X, कैपिटल X से लिखते हैं, ठीक है. कैपिटल X स्क्वायर, ठीक है, कैपिटल X is iota CT x y z. Okay, it means this is the vector. आप इसे x भी लिख देते हैं, बाद लोग r भी लिखते हैं, लेकिन हम ज्यादातर इसे x लिखते हैं. अब आप, मेरा ख्याल है कैपिटल X लिख लो तो ज्यादा बेहतर है. ये टर्मिनोलॉजी जरा आगे भी ज्यादा यूज होती है इस वजह से, ठीक है. तो कैपिटल, ये 4 वेक्टर में, ठीक है, where x is the element of the Lorentz transformation, okay, the 4 dimension. Okay, and okay, 4 velocity क्या है? Yeah, this is a 4 vector. What is the 4 velocity? Velocity. What is the velocity? The velocity is the rate of the change, your first derivative of position with respect to time. So now in 4 dimension, this is a position. Okay, and these are actually actually हम इसे वैसे 4 वेक्टर में और तरीके से लिखते हैं. चलो अब आप इस तरीके से लिख रहे हो, इस तरह, ठीक है. अच्छा, this is equal to this. Okay, okay. The velocity, what will be the velocity V? Now, what is the 4 vector in velocity? Yes, but in relativity, in Lorentz transformation, time is नहीं. In relativity, in Galilean transformation, time is constant. Yes, आप एक time और उससे derivative ले लेते हैं. But in relativity, time is not constant because for A frame the T A, and for B frame that will be a T D. So time is different for relativistic. So हम यहाँ T तो नहीं ले सकते क्योंकि the time is using here. This time is variable. Okay, but we have to take the derivative, that is the proper time. This is defined. This is defined as proper time. Now the question is, what is the proper time? This will be the constant. Constant. That will be not changed. They will be the same for every frame. This time is variable mean different for variable mean different a change with मतलब different for different variable we know that different frame of reference, but this is the proper time. This will remain in the same for frame same for every frame of reference. This will be the same for every frame of reference. Do you know what is the that time that will be a same? Not I must not. अच्छा यार ये थोड़ा सा वर्ड और हो जाता है. Mean this is not part of this dimension. Not I must not mention that is defined as a proper time. Okay. Proper time क्या है? जो कांस्टेंट रह रहा है, जिसके लिए इवेंट जो है वो कांस्टेंट रह रहा है, इवेंट जो है उसके सामने हो रहा है, जो प्रॉपर टाइम है. व्हाट विल बी द प्रॉपर टाइम? यस, आप गेस करो, मैंने पहले जिक्र नहीं किया, लेकिन प्रॉपर टाइम क्या, कौन सा ऐसा टाइम है जो इवेंट के लिए बिल्कुल एग्जैक्ट आएगा, मतलब उसके लिए इवेंट की लेंथ में या चेंज नहीं आएगा. मैंने पिछली दफा, ठीक है मैं लिखवा, डेफिनेशन मैंने नहीं लिखवाई लेकिन अभी लिखवा देता हूँ प्रॉपर टाइम की. लेकिन मैंने प्रॉपर टाइम द टाइम जिसके लिए इवेंट स्टेशनरी है, इवेंट सामने हो रहा है, इवेंट की पोजीशन नहीं चेंज हो रही. व्हाट इज द प्रॉपर टाइम? प्रॉपर टाइम एंड इट रिप्रेजेंट बाई टॉप. इसे कहते हैं टॉप, इस सिंबल को टॉप है, टॉप. ये टॉप के लिए भी आप यूज करते रहते हो. टॉप टी किसके? प्रॉपर टाइम के. TAU में टॉप पे भी टॉ यूज करते हो आप, मेरा ख्याल है सिंपल. ठीक है, टॉ कहते हैं, TAU. ठीक है, प्रॉपर टाइम. अच्छा, व्हाट इज द प्रॉपर टाइम? द टाइम the time for frame of reference which is attached with the event. The time for frame of reference. Frame of reference I have already explained, that is observer. If observer is attached, if observer is moving with the event, I have already explained it in the time dilation. अगर आपको रेफरेंस याद हो तो टाइम डिलेशन, मैंने टाइम डिलेशन वाला टॉपिक फॉर रेफरेंस टाइम dilation topic. There was a two time, if you remember that one time was a जो कि स्टेशनरी फ्रेम में था एंड टी स्टेशनरी था, याद होगा, जो स्टेशनरी था जिसके लिए बॉडी यानी फ्रेम ऑफ रेफरेंस स्टेशनरी था और इवेंट मूव कर रहा था. इवेंट क्या कर रहा था? इवेंट मोशन में था. ये जो फ्रेम था स्टेशनरी था, और लेकिन टाइम हम इसे क्या कहते हैं? टाइम फॉर, जिसके लिए इवेंट क्या कर रहा था? मूव कर रहा था, और दूसरा क्या था, टाइम, जिसके लिए इवेंट जो है स्टेशनरी था। इफ यू रिमेंबर, मैं बताता हूँ, एक मिनट पहले नोट कर लो फिर बताता हूँ। एक मैंने बताया था टी मोशन, एक जिसके लिए टी स्टेशनरी था, डिवाइडेड बाई 1 माइनस वी ओवर सी स्क्वायर। ये मैंने प्रूव कराया था आपको, याद आया? ये टाइम, दिस स्टेशनरी टाइम, द टाइम फॉर विच द इवेंट इज स्टेशनरी, ठीक है, दैट द टाइम विच इज द फ्रेम, द ऑब्जर्वर विच इज हु इज मूविंग विद द इवेंट, जो इवेंट के साथ, यानी जो जहाज में मुसाफिर बैठा हुआ है उसके सामने ही कोई इवेंट होता है, जहाज में ही होता है, तो दैट विल बी डिफाइंड एज अ proper time. This is a proper time. This time will be defined as a proper time. The stationary time, that is the stationary, that's for the time for which the event is stationary. The time that is moving with the time for, that is moving with the event. Event के साथ साथ move कर रहा है. Okay. So that time will be defined as a proper time. Okay, got it? So if I represent it with the t, I will represent it this is actual time, ठीक है, this is proper time, and this is 1 minus v square over c square. ओके, यहाँ कहीं एयोटा तो नहीं था? ये देख लेना, मुझे नहीं पता, याद नहीं आ रहा। एयोटा तो नहीं था? अच्छा जी, दिस इज, एक मिनट, दिस इज अ प्रॉपर टाइम, ओके, एंड दिस टर्म इज आल्सो डिफाइंड एज गैमा। आई हैव ऑलरेडी गैमा टा, यानी दिस टर्म गैमा इज एक्चुअली, गैमा इज where gamma is okay. This is defined as a proper time. Okay. Now, if I ask the definition of what is the proper time, you will be define the time observed. The time, अच्छा, इसको मैं बिल्कुल ज़्यादा वाज़िया तौर पे लिख दूँ, मेरा ख्याल है ये तो मैंने आपको जनरली लिख दिया था। अब मैं ज़रा इसे टाइम, कौन सा टाइम, इसे मतलब अगर मैं ज़्यादा फॉर्मली लिखूँ तो क्या होगा, द टाइम ऑब्जर्व्ड फ्रॉम ऑब्जर्वर वो भी डेफिनेशन ठीक है, वो भी लिखी रहने देना, मूविंग विद द इवेंट, ओके, द टाइम ऑब्जर्व फ्रॉम ऑब्जर्वर, वो वाला भी लिख लेनी, वो वाली भी। दूसरी डेफिनेशन क्या लिखाई थी, टाइम और फ्रेम ऑफ रेफरेंस fixed with the events. Okay, and both are the same definition. Okay, if the observer or frame of reference is fixed on the event, along the event, or they are moving along the event, then that will be defined as a proper. That time will be defined as a proper time. And if you have a 2 clock. Okay, if I have a watch, okay, and one watch, if and one person is moving in a plane and he is also have a watch and observing the time of the event happening in the plane, then the proper time will be observed from the passenger sitting on the plane. Okay, got it? Okay, so this is a So this is proper time, this is a 4 vector. Okay. In a tensor sense, we usually write a 4 vector in the, sometimes we write any indices on it, and that we usually write in the form of here alpha. मैंने इंडिसेस दे देते हैं आम वेक्टर से ट्रांसफॉर्म करने के लिए. इसको ज़्यादा एक्सप्लेन मैं टेंसर में आपको बाद में करूंगा या आपके टेंसर वाले टीचर. आप सिर्फ इतना समझ लें कि हम ऐसे वेक्टर को जो है वो 4 वेक्टर को अल्फा से रिप्रेजेंट करते हैं. ठीक है, गॉट इट. अल्फा बीटा कोई भी, यानी ए बी सी, या ए लिखना चाहो, अल्फा मुश्किल लग रहा हो तो ए लिख लो. ठीक है, हाँ जी. अच्छा, ये हो गया प्रॉपर्टी. अब हमारी बात ये रह गई कि 4 वेलोसिटी निकालेंगे कैसे. ये 4 वेलोसिटी आ गई. एक 4 वेलोसिटी का, ओके कोई बात. 4 वेलोसिटी, ये टॉपिक तो पूरा कर, सिर्फ वेलोसिटी का. व्हाट इज द 4 वेलोसिटी? V alpha that is equal to d. अच्छा, इसे भी मैं फिर अल्फा की तरफ लिख रहा हूँ. ठीक है, dx ओवर dt, और सॉरी dt नहीं, deta. ओके, so your question is about what about the graph. ठीक है, तो in 3 dimension, firstly we have to understand what is the 3 dimension. Okay, in 3 dimension, you know the graph is like this will be x, y and z, and all are making angle 90. Yes. Okay, it may be easily observed that if you draw, if you consider the corner of a wall, you in a room, you or a box, you may see that this is making this axis is also making 90, this axis is also making 90, and the height is also making in such a way. Okay, in if you consider the corner of wall as a origin, then or a reference point, then there is a 3, 1, 2 and 3 in the 2 axes are in a plane and 1 axis in a space. So to be considered in 3 dimension, in 3 dimension in real life, that is a very simple. But considering 4 dimension is a very difficult, because we live in a 3 dimension, because we usually are familiar with the 3 dimension, not a 4 dimension. But if you observe, as I have already explained, that your 4th component is x naught, that is iota ct. Yes, the 4th component, the remaining component is x1 is equal to x, x2 is y, x3 is z. The remaining component is the same. The problem is about the 4th component. How we will draw the 4th component? So 3 component will be drawn in the same way as I have already explained. The xy in one axis and z along the space. Now the question is where I can draw the, because all 90s are completed, but how we may draw the 4th axis, the time axis in our graph? Yes, that's a good question. Actually, kya hai? We know that, yes, that is not exactly time, but ct, time multiplying with the speed of light. The 4th component is, it is defined as a time component, but actually this is not only the time, but speed of light is multiplying. But speed of light is a constant, so variable is only the time. You are right. Okay? That's why that component is defined as a temporal component or a time component. Why that is called time component? Because iota is constant, c is constant. Only the t is, because speed of light is constant for all observers. Only the time is varying. That's why we consider that this is a time component. You are absolutely right. Okay? है? ये तो हमारा वहाँ से ड्राइव किया था, हमने बताया था, ये बताया था. अब हाँ, ये ड्रा कैसे होगा, अभी भी ये क्वेश्चन है कि ड्रा क्यों। आप यू नो दैट इफ वी ड्रा दी if we consider the complex number, that will be combination of two numbers. Whenever we consider the complex number, they will be have a two part. One is here A and B is a two real number. A and B are real number, but iota makes this component as imaginary number and this component as a real number. So all complex numbers has a if that is that have a imaginary number, imaginary part, and that has a real plus imaginary part, or real plus iota real. May I write in this way? Yes. Okay. And you may see that the real number is this iota real. They are making angle 90. ठीक है, that is understood. अच्छा, now here x, y and z are these are 3D, but in all x, y, z are real. This is a element of R3, 3 dimension. ये आपने ये भी आपको असल में लीनियर जबरा आप लोगों अच्छे तरीके से नहीं पढ़ते इतने, मतलब या पढ़ाने मतलब मैं ये नहीं कहूँगा, लेकिन आप अच्छे तरीके से उसको नहीं देखते। उसमें आपने एक R3 की जितनी डिमेंशन होगी उसके ऊपर वो आ जाएगा। तो सो दिस इज अ एलिमेंट ऑफ R3, ये रियल नंबर है। तो रियल जो है इमेजिनरी हमेशा इसके ऊपर क्या बनाएगा, एंगल 90. So fourth part is imaginary number. Okay, that is making an angle 90 with all these three. मैं बता देता हूँ फिर. This is iota CT. Here CT is arranged. Okay, and this is it. जैसे कि मैंने कहा रियल को iota के साथ मल्टीप्लाई कर दो, they will make a 90. All these are a free space, the real space जो आप आमतौर पे देखते हो. This is x, y, z. Okay, and this is imaginary part. ये रियल में है और this is imaginary. ठीक है, so that's why that's 4 dimension. Will this make a 90 with all this real? So this ICT will be orthogonal to R3. यानी इन तीनों पे, यानी ICT will make a 90 with the x, y and z. इन तीनों के साथ वो 90 एंगल। ये तो क्लियर है ना, एक्स वाई जी का 90 कैसे बनता है। ये रियल में है और इमेजिनरी स्पेस क्या होती है, ये यहाँ नजर आ रही है। इमेजिनरी स्पेस जैसे ही किसी चीज को नंबर को इमेजिनरी से करेंगे वो रियल के ऊपर क्या होगा, दिस इज नॉट रियल लाइक दिस, इमेजिनरी रियल। ठीक है, whenever a real number is multiplied with the iota, this will make a 90 with the real. ये वो नहीं है, ये imaginary space. ये this is not like आप जैसे real space consider कर, this is not real space, this is a imaginary space. यानी ये 90 बना रही है इन तमाम के ऊपर। ये real है, नहीं समझ, ये एक स्पेस है, ठीक है, समझ लो ये रियल है, ठीक है, इमेजिनरी इसके ऊपर फॉर्म, ये रियल है, ये आपका वो 3 डिमेंशन है और ये जो है आपका आयोटा सीटी है। ठीक है, बात नहीं समझ, हर इमेजिनरी नंबर, हर जिसके साथ आयोटा मल्टीप्लाई हुआ है वो हमेशा रियल के ऊपर क्या बनाएगा, एंगल क्या बनाएगा रियल के साथ, 90। तो ये आपकी रियल है, ये एक्स वाई जी तीनों क्या है, रियल है, इसमें कोई कंप्लेन। अब मैंने एयोटा से सीटी को मल्टीप्लाई किया है तो ये किसके साथ होगा, इन तीनों के ऊपर क्या होगा, 90। नहीं, गॉट इट, हैव यू गॉट इट? So that must be a very clear. Okay, so that is a very important point. Okay, so I must be explain it. Thanks for helping me to introduce it. Okay, समझ आ गई है? तो मैं आगे चलूं। Clear हो गया? Okay, so this was all about the why this is default. पिक्चर बना लो, ठीक है. Okay, 100 rupees is appearing. Okay, GR has 100 rupees. Okay, so got it? May I erase it? Okay. So next question is we was discussing that this is the gamma, so this is gamma, okay, okay, gamma, okay, okay, and tau will become, so from this equation, tau will be equal to T over gamma, okay, may I write it? Okay, and d tau will be जी अच्छा परपेंडिकुलर है, हाँ यस. या अच्छा, इसे लिखने से इस तरीके से बाद में आपने उसमें भी देखा होगा, इसको लीनियर अलजेब्रा में ए बी की फॉर्म में भी लिख सकते हैं कि दिस पार्ट विल बी अ पार्ट ऑफ रियल एंड दिस विल बी रोटा बी, इस तरह भी लिखते हैं, ठीक है. इसको कोमे की फॉर्म में भी लिखते हैं. यू आर राइट. ओके, गॉट इट. ठीक है. एक्चुअली जब भी किसी चीज के साथ एरोटा करते हैं तो वो एंगल 90 बनाता है उस कार्ड के साथ, ठीक है. वो हम सिंबॉलिकली ज्यादा हम जो है ना एडवांस लेवल पे या आपने लीनियर अलजेब्रा में देखा होगा उसको ब्रैकेट की फॉर्म में इस तरीके से लिखा होगा कॉम्प्लेक्स नंबर को, ठीक है. ओके, डी टा विल बी बट 1 गैमा. हाँ जी, ये आपके पास ही आ गया, ये चीज यहां से आ गई. बाय पुटिंग दिस वैल्यू हियर, ओके, you will get V alpha will be equal to divide over denominator, the denominator, so when we divide it, it will be beta. नहीं, T equal to gamma tau, this implies that tau is equal to 1 over gamma T, ऐसे. Okay, got it? नहीं समझ आई? यार गैमा टी मल्टीप्लाई हो रहा है ना, इधर जाएगा तो क्या यार, ये वही चीज है. ये पहले इधर देखो, मैं दोबारा बोलूं. T is multiplying gamma with the tau, ये समझ आ गया. इससे अगला स्टेप करो तो दिस implies that tau is equal to, ये वहां जाकर डिनोमिनेटर बन जाएगा T ओवर, यही लिखा था गैमा, D tau will be dt गैमा. आप ठीक है, ये वही है, ठीक है, उसी तरह. आप समझ आ गई क्यों कर लिखा था. ओके, ये बाय पुटिंग दिस वैल्यू हियर, V alpha will become D over dt over gamma, yes, and it means that will be so when it comes here, this will become sorry, okay. ये dt मीन ये वाला t है, ठीक है, सॉरी मुझे इस फॉर्म में, इसको हम इस तरह भी लिख सकते हैं, यानी ये स्मॉल p था, मैंने उसे कैपिटल में लिख दिया, ठीक है। तो dt dx ओवर dt dy ओवर dt dz over dt. Okay, derivative of t with respect to t will be 1, and so that will be iota c, gamma is multiplying v x, sorry, this is x, vx vy vz. Okay, gamma is multiplying this. Got it? Yes, sir. So this will be your the 4 velocity. Okay. Got it? May I erase it? Thank you. Okay. If this is a 4 velocity, what is the momentum? For momentum, momentum is, as you know, linear momentum. What is the linear momentum? For linear momentum. So what will be the linear momentum? Yes. Linear momentum. Mass, yes. Linear momentum is product of mass and velocity. This is in a simple definition in 3 dimension. Okay. But 4 vector क्या होगा? This is a p in 3 dimension. Okay. So 4 vector क्या होगा? Mass, rest mass multiplied by v alpha. Yes. And v alpha is m naught, but v is gamma ic vx vy vz. This will be equal to this. Yes. Okay. This is okay. Okay. So P alpha is m naught gamma ic, we multiply m naught gamma vx, m naught gamma vy, m naught gamma vz. Yes. And these are the component of, this is not component, the first is not component, this is not component, time component. Okay, momentum का time component, linear momentum, ये linear momentum का 0 component, this is first component, this is second component, this is third component. Okay, yes, got it. First component is defined as x component, 2 component is defined as m and z. Okay, so from here px is equal to, if we compare the coefficient, okay, px is equal to m naught gamma vx. May I write it? But gamma is one minus v square over c square. Coefficient. This is equal to, sorry, I must mention, if you are confused, this is this, this is this, and this is this. Okay, and this is this. Yes. Okay. This equal to this. This is Vx. Okay. But actual definition of momentum, linear momentum, is m Vx, mass multiplied by Vx, velocity. So if I consider this and this is a Vx, okay. So this term is this mass is equal to this. Okay. So in relativity, mass will be not constant, but mass will be equal to, if we compare this mass with this will be equal to m naught divided by 1 minus v square c square gamma. So this will be the relation for the relativistic mass. So this is defined as a relativistic mass. So the mass will be not constant, but increasing the speed of light. If you increase the speed of light, mass will be, for example, if become a c square, the mass will be increased, because this term is less than 1. As we increase the speed, मैं दोबारा साफ करके लिखने के लिए, वो ठीक है. अगर आपने नोट किया हुआ तो कोई मसला नहीं, मैं सिर्फ इसे साफ करना चाहता हूँ. 1 माइनस v स्क्वायर ओवर clear? 1 over c square. So mass will be relativistic mass. Okay. Have you got it? क्योंकि आप बिल्कुल खामोश हो. ठीक है, समझ आ गई है? So this is a relativist. Okay. So if I erase this, okay. Okay. So your relativistic mass is m naught over 1 minus v over c square. But as you know that 1 minus v over c square is less than 1, okay, because so it will, और जितनी जितनी इसकी वैल्यू बढ़ती जाएगी, सो मास की वैल्यू बढ़ती जाएगी. सो मास will increase as velocity v will increase. And if we consider v equal to c, okay, if we consider the v equal to c, then what will become? Then m equal to m naught 1 minus v over c square, m naught over 1 minus c over c. Okay, this become a 1. 1 minus 1 क्या होता है? So it become an infinity. The mass become an infinity. Okay. So if you got the speed of light, then you will touch the infinity mass. But this was a general formula. Mostly people expected, but according to my paper, my research that is presented in ICTC. Okay, according to If we consider V equal to C and C, if we put value of C divided by C, 1 का स्क्वायर 1 ही होता है. ये स्क्वायर ही है. Okay. So, but according to my presented in ICTP इंटरनेशनल सेंटर फॉर प्रैक्टिकल फिजिक्स, ठीक है, इटली, ठीक है, इटली. M is M naught divided 1 minus V over C square is a formula derived for only when we approach to C. Drive only for when V is less than C or we approach to C, not V greater than C or not V less than C. So there is no cutoff in relativity for mass moving equal or faster than speed of light. Due to this, because that was becoming the mass infinity, that's why people always claim that nothing can be touches the speed of light. Okay, but I have proved and presented my paper on the ICTV that this formula was not actually derived for that, but it is derived only for the if V is approach or less than or approach. If V greater than or less than, then the formula will be different. Okay, so this is formula is not, so that's why the claim cutoff, that is wrong. Cutoff means that must not be forbidden. Okay, so so this is about the relativistic mass. If अगर पेपर में ये आता drive the relativistic mass, then you must know कैसे आपने drive करना है. Okay, got it. The next topic is about